Well, hello there, and welcome back to Nikki Does. This is another one of those topics where I got into this a little bit, and as I got into it, I thought this might make a great video, or at least a great short video. This is a power strip from Amazonia, and I was about to start using it, and I realized, I really don't want the on-off switch there. This is going to be for some 3D printers. And we really don't want to turn off the 3D printer, so there's no cover over this, there's no nothing, so if you bump it, it'll turn off and ostensibly destroy the 3D print. My intention is to plug this into a UPS, so what's the point of a UPS if you could just bump this off, right? So I got into the meat of her, basically took it apart, found some cool extrusion features. This is totally a side point, not the main point of the video, but I did find some cool extrusion features to put these two together. Let's see if I can get the camera up high enough as I distract from the original point of the video, which is the safety switch. But I like this geometry in here for putting two extrusions together, and you can bet your bottom doll hair, euro, shekel, rupee, or dung that I'm going to be stealing that feature right there for some of the extrusion design work that we've been doing recently. Anyway, that got the box section apart here. I took that box section apart, found out, of course, what you would expect in something like this is a number of outlet taps wired in parallel, both line, neutral, and ground. And you can see also there is an MOV in here with, for some who knows why reason, there's a shrink wrap over it, maybe to keep the MOV from the electrode from separating from the MOV. That would be my guess when they put this together. Something like that. But otherwise, and there is some naughty in here. We'll see if we can find that on the camera. Yeah. The neutral wires are hanging out a little bit. Kind of crappy. Not at all what I would like. Reminds me of the other long Amazon Basics outlet strip that I have up there, which you can't see. And that one totally failed inside because some stuff shorted to the case. Fortunately, the ground did its job in that case. But again, I digress. What a disgrace that is that I digress. So here's what I'm going to do to test this thing's ability to produce quite a bit of current. I've got here the ability to produce 18 amps at whatever voltage. So I must have gone to the same wiring school that they did, huh? So what I'm going to do is put that 18 amps on here. It's not on right now. We'll go something like this so it's not really shorting out. Although the point of this is to short out, just not right there. So we'll get that attached to the test clips attached here to this. We'll go one up, one sideways. That should be pretty good. And then the other end of it, I found out of my trash from something I had cut the cord off to do something else. I found this power cord and made it into one of the world's most intelligent power cords ever. So you can see there, we are soldered together. If the word has an L, we ought to use it. So we're soldered together. If you watch Mr. Carlson's lab, he says soldered, but give him some leeway because he's Canadian. All right. So now, if we turn on the power supply, which can put out 18 amps, and we're set to 10 volts, so we can get all 18 amps through there, we are now about to cook 18 amps through there. So let's do this. All right, and we are producing 18 amps. We have about a, what do we have it set to? 5 volts? 10 volts. So we have about a 7 volt drop through this thing, and yeah, that's not really great wire for 18 amps. I mean, it's certainly going to start getting warm. I'm putting 18 amps through here and it's not resetting. So that's no good. I mean, we're still putting 18 amps through here, so we're overloading. My max on this is 18.2, so I'm not sure that another 0.2 volts is going to make really any difference whatsoever. It's what, 8% additional? Yeah, that's definitely... It's starting to get a little warm there. I can feel it. Not touch warm, but certainly warm. It's not resetting. I don't expect it to reset instantly at 18 amps, but I do expect it to reset at some point. So maybe we'll have to edit this video. I'm going to pause this and we'll come back. Well, about 5 minutes has elapsed, and we're still powering 18 amps through this thing, and it's still getting warm. And I noticed something, and I said, which I tend to do. On this sticker, I noticed that it's made in China. Not only did I notice that it's made in China, but I noticed that it's apparently been safety rated to the SGS CUS standard. Now, I've done this work before, and I've done it with UL, and I've done it with CSA, TUV, and Met Labs. And those are, to varying degrees, recognized in the United States and certainly in other countries too. But then I noticed there's no UL, but I did notice that it conforms to UL standard 1363. And it's certified to CSA standard C22.2 number 308. Now, I don't even know if I'm going to bother looking up UL standard 1363 because this really should conform to, well, a couple different standards for, really a couple of different standards for touch safe and for the UL National Electric Code safety and some other aspects of safety and legality for insurability. And I'm not seeing that this is really anything. I've played this trick long ago where I said we conformed to ISO 9000 standards when I was about 22 years old. I advertised in our brochures that we had a quality system that was in conformance with or in compliance with ISO 9000. And my thought was, if somebody said, are you ISO 9000 certified and who is your registrar? I'd be able to say, no, we don't have anything that registered, but we're attesting that we're conforming with them. We believe we've got everything in place to do that. And I think we did, but we didn't want to go through, my little company didn't want to go through the expense of hiring an auditor or a registrar to come in and give us the mark. Now, I don't know if that stands for super awful safety, with awful being a G. I mean, typos are certainly the norm here, as we can see. I have no idea what this SGS mark is. I will take a look. Well, let's do that right now. Well, it turns out SGS is a nationally recognized testing laboratory for the United States. It is a fairly small one, even smaller than Met Labs, which you may not have heard of. And it seems they have quite a bit of fraud going on with them because I could submit this, and I may do that, submit the video and say this 800667 mark does not seem to me to be accurate. I don't think they probably went through the effort to get this. They just found the least popular mark and put it on here so they can say they conform to an NRTL standard. I'm not real thrilled with this. Now it's been about 9 minutes and it still hasn't tripped, and we're taking 18 amps through. This is definitely warm. I don't think it's unsafe warm. So if we were drawing 18, and we are drawing 18 amps through a 15 amp cord, it's not unsafe warm yet, but it's definitely warm. And we should really be tripping this by now. Remember, it's the amps that kill you. So anyway, I think I've spent enough time on this. I will almost certainly have to leave this. It's tripping off. Look at that. At 8 minutes 41 seconds, it is in fact turning off. I'm going to give this a thumbs up, except for some quality issues in here, which not the worst thing in the world, but certainly not the best. I'm going to give it a thumbs up. I still suspect that's not correct, but I'm going to give it a thumbs up. So I will now have to build something to keep this covered for inadvertent turning off, but we will certainly leave it in line. Well, thanks for watching.